looking at gradient, or how to calculate the gradient of a Cartesian plane. So again, a gradient meaning something, or the slope or the steepness of a line. So hopefully by the end of the lesson you understand what these four things are, and also the rule of how to calculate a gradient, and you can't calculate that from there. So let's go have a quick look at what is a gradient. So the definition of a gradient is the measure of a slope or the steepness. Okay, so it's a measure of a steepness of a line, or the slope. Okay, and we do that by calculating using a particular rule, and we use this rule here. So gradient equals rise divided by run. It's important that you copy that down. So basically what that means is that it's an increase in the y-axis. So again, our y-axis, we've got our x and y-axis. As our y-axis increases, so this way, so does our x-axis, and it creates a line. Okay, and that's what we call our gradient. We calculate that by dividing our rise divided by our run. So we have two types in this case. We can have a positive, we can see sloping up, and a negative, which is sloping down. But we're going to give you a couple of examples now so you get a better idea of how to calculate that. So if we use this slope here, or this gradient here as an example, and if this was set up in a Cartesian plane with boxes, etc., what you'd notice is that it's going up. Okay, so it goes up the y-axis, which is the rise, goes up 4, and the run, which is the x-axis, goes across 2. So what we do, we simply just put that into our formula, which is rise divided by run, which means 4 divided by 2, which gives us 2 divided by 1. It gives us an answer of 2, and that's how we calculate the gradient. We can also have a negative gradient, so you see in this case the slope going down. And what we do there, that means that the rise and the run is the change in the y and the x-axis. Now in this case, you'll see that the y-axis is actually going down. So it's going down to a negative. So it's actually a negative number. So because it's going down, the increase or the change in y is actually down 3. So that's why we have -3. And the increase across there is the x-axis is 2. So we're going to look at an example soon of how to do that, but always considered a positive when it's moving from left to right. Now we've got a couple of different types here. So if the y decreases and the x increases, like this example here, okay, we call that a negative gradient. Now if the gradient is a straight line across, so this one here, we call that a 0. And finally, if it's a vertical line, which just goes straight up and down, we call that undefined, because you can't divide by 0. So let's have a quick look. I want to show you an example of what that might look like using an example. It's a better visual understanding of what that looks like. So you can see here we've got our Cartesian plane. We've got 2 points. Now as I change the y-axis, so if I move this point up here, let's have a look. We'll see what happens here. So this is basically an example of how you calculate the rise and the run and what that means. So you've got your rise is your y-axis. Okay, so from the point it goes up 2. So you can see my rise is 2. And my run from the point goes across 4. Hence I have 2 over 4. The direction is positive, which we know because it's sloping upwards. And that's how we calculate. So just watch and observe what happens as it goes across. So we can, by changing the rise and the run, we might move it into different spots. You'll see how that calculates. Now what I'll get you to focus here on the direction. So as it is moving from there, it is positive. Okay, so as it comes to a horizontal line, it becomes a 0. And then as soon as it goes below that, it now becomes a negative gradient. And you can see the negative number response there. So by changing that, the way that moves around, we get our rise and our run, and it affects basically the direction of the gradient. So now let's do a couple of calculations to show how we can do that further. Examples here that we're going to be able to define and work through here. The first question asks us to find what A, B, C, and D, and define what these types of gradients are. So if we focus here on A, so as you can see, it's going down negatively to the right. So it's going to be a negative gradient. Now if I look now at B, which goes straight up and down, okay, that's going to be undefined. Okay, so remember that it's only got one straight line from 0 from there. It's undefined. C, I can see this example here. It's going up to the right, which means it's a positive gradient. And finally, if you remember from our notes, D goes straight across the horizontal, which means it's 0. Okay, so we calculate that as 0. So we've got all 4 types there as an examples. Make sure you remember and identify those. Now let's do a quick mathematical example of how do we calculate the gradient. So what we'll do here, we're going to find the gradients of these lines. We're going to firstly write the rule. Remember, gradient equals rise divided by run. And I'll just put in the data here. So I can see starting from my point, my rise goes up 3. And a good tip is to usually just draw a triangle so you can see that how it fits in there. So my rise goes up 3. My run goes across 2. And if I calculate that, that equals 1.5. So my gradient in that case is 1.5. Now we're going to use a negative example. So again, gradient equals rise divided by run. I simply input or substitute the data in from here. I'll draw my triangle from between the 2 points. So my rise is actually 4, but it's going down. So it's going to be negative 4 divided by the run, which goes across this way, moving up 4. So I have negative 4 minus 4, which actually equals the answer of negative 1. So my gradient here is negative 1, and that shows you the difference between a positive and a negative gradient. So make sure you understand each of those 4 points there as we go through. We're going to be focusing a bit more in class and ask any questions as we go. Thanks, guys.